To say that a graph is symmetrical about the y-axis means that we can treat this y-axis as an axis of rotation. If we were to flip this graph about the y-axis, it would look the same after we flip it. Here we have the graph of y is equal to x squared. Let's notice that we have the ordered pair 2, 4 on the graph, but we also have the ordered pair negative 2, 4. This is a characteristic of a graph that has y-axis symmetry. If a graph is symmetrical about the y-axis, every single ordered pair on that graph will have a corresponding ordered pair where the y value is the same, but the x coordinate is opposite in sign. So for any ordered pair that we pick that's on this graph, we know that the opposite x value with the same y value is also on the graph. We can see that that's true for the ordered pair 2, 4, but when we have y-axis symmetry, it must also be true for every ordered pair on the graph. Similarly, to say that a graph has symmetry about the x-axis, that means that the x-axis can be treated as an axis of rotation. And if we were to rotate this graph over the x-axis, it would look the same after we flip it. The graph that we're looking at here is of x is equal to y squared. And let's take a look at the ordered pair 4, 2. And notice that the ordered pair 4, negative 2 is also a point on the graph. Generally speaking, every single xy ordered pair on this graph, we'll just pick one up here, must also have another ordered pair on the graph where the x coordinate is exactly the same and the y coordinate is opposite in sign. If this is true for every single point, no matter where we look on the graph, then we say that this graph has x-axis symmetry. Now let's look at a graph that has symmetry about the origin. A graph is symmetrical about the origin if we were to put a pin in the origin and then rotate this graph 180 degrees, basically turning the graph upside down. If when we rotate it in this way, we end up with the exact same collection of ordered pairs, so the graph would look exactly the same upside down or right side up, that's a characteristic of a graph that has symmetry about the origin. In the graph that we have here, we see that the ordered pair 2, 3 is a point on the graph. If we rotate this 180 degrees, or basically turn it upside down, that ordered pair is going to rotate over to the ordered pair negative 2, negative 3. And generally speaking, any xy ordered pair that's on a graph with origin symmetry must have a counterpart also on the graph where the x coordinate is opposite in sign and the y coordinate is opposite in sign. Now, if that's true for every single ordered pair that we could pick, no matter what point I choose, there's another ordered pair where the x and y coordinate are opposite in sign, then this is going to be a graph that has symmetry about the origin.